Okay, um, in this video, we will have a rundown on an Anki deck that was created in order to prepare for the for the grade 11 third quarter statistics exam. Um, I'm already first year college, so it's been more than a year since I've made this. Just like the chemistry Anki decks. So we'll start now. Okay, so we have two major types of data. Uh, Number one is categorical. Number two is numerical. So yeah, just two types. For categorical, it's qualitative. So pertaining to the quality. For numerical, this is the quantitative aspect. It's divided into two subtypes. The first subtype is discrete. So it doesn't have decimals, and there are things that cannot be counted as half. So whole number whole numbers can only be countable. For continuous, they can be measurable. That means, I believe, decimals could be examples under continuous. So everything that was discussed just now can also be um, seen in this form. So two types of data, categorical and numerical. For categorical, we have nominal and ordinal. Uh, Although I didn't specify the subtypes here. Nominal, we have categories. Ordinal, there's an implied order. Discrete has only particular numbers, and continuous is any numeric value. It could also be decimals, I believe. Particular numbers, um, perhaps you can say that only integers are allowed in discrete because decimals are not considered integers. That's all. Next, we have two kinds of statistics. First, we have descriptive statistics, and second, we have inferential. For descriptive, basically we get data and we talk about it. We describe um, in layman's terms. We just describe. For inferential statistics, we draw conclusions based on samples and we infer something from the data. And we infer if the population, for instance, behaves the same way. Okay, so in this image, for descriptive, organize, summarize, simplify, describe, and present data. For inferential, we generalize from samples to populations, and we perform hypothesis testing. So there are many formulas that we could use for hypothesis testing, depending on the situation that we are given. Uh, Population proportion, whether we use right-tailed or two-tailed test, stuff like that. Um, I've already made a series teaching that lesson in statistics. That's actually fourth quarter. This one is third quarter statistics. So this came first. Test hypothesis is more advanced. Anyways, we also make predictions in inferential stat. Okay? Blank is a small part of the population. Always remember this is the sample. So yeah, a small part of the population, usually they have a common characteristic. So for example, out of a population of all students in, let's say, MIT, we are just looking to examine a part of the entire population in MIT. So for example, we just intend to identify certain things about, say, class 184, a specific class or a specific group of teachers, stuff like that, or staff. Okay. Um, Interval, 0 is meaningless, and temperature can be in degrees Celsius or degrees Fahrenheit. Ratio has a true zero. The length has a ratio variable. I think these two, interval and ratio, are two of the four levels of measurement. Sorry, levels of measurement. In this flashcard, I just wanted to clarify the difference between the two because usually uh, the definitions are interchanged. Interval and ratio share the same numbers. The difference is coursed through the context, so be careful with the context. Interval is more on temperature, ratio is more on ruler. In a ruler, there cannot be a negative integer. you can't say a specific object measures negative 43 centimeters, right? So it brings us to the idea that for interval, since temperature is an example under interval, we can say that negative values can be counted in interval, since it's possible to say that the current temperature in Alaska is negative 3 degrees Celsius, for example. Although that's just from my personal schema. I'm not sure about the actual temperature in Alaska, like basically on average, but I think you get what I mean. Interval allows negative integers because again we're dealing with temperature there. So what's the difference between interval and ratio scale? For ratio scale, as said earlier, more on ruler. Interval, more on temperature, the thermometer. Okay. What type of data is each of the following variables? If there is any ambiguity, explain why the answer is unclear. Okay, so we already have the answers for B, C, and D. For letter B, the number of peanuts in a can of mixed nuts. This is discrete numerical. So the number of peanuts, so numerical. Occupation of a mortgage applicant. This is categorical data. We can't really quantify it in any way. Uh, Letter D, flight time from London Heathrow. I'm not sure if this is pronounced correctly by me. To Chicago O'Hare. Continuous numerical. So we're talking about time, so it has to be in digits. Continuous for some reason. Length of a TV commercial. Length. So this is definitely numerical. Continuous numerical. Any numeric value, because the length of a TV commercial can be in decimal form. So for example, the TV commercial lasts 2 minutes and 2 seconds, 2.8 seconds. So there's a decimal. That's only applicable in continuous. If ever it was discrete, then it wouldn't make sense because you can't really control the length of a TV commercial. You can't prevent it from reaching a decimal value at one point. So we have categorical, numerical. Just take note of the examples here. I'll move to the next flashcard. Measurement levels. Categorical, we have okay. So what we were talking about earlier were two measurement levels under the numerical category. So we have interval and ratio. I won't explain this anymore. Let's focus on what hasn't been mentioned yet. Categorical, we have number one is nominal. Yeah, nominal. Identify what names are common. So like for example, there are two people studying in a certain institution called Life Academy who have the name, well, basically who are named Mika. So there are two Mikas in this institution. For ordinal, there is natural ordering. The data is expressed in words. So for example, you wanted to see how customers rate the quality or the experience they based on their stay in a certain hotel. So from best to worst, or in the context of dining at a restaurant, you're given uh, the opportunity to ask for feedback coming from customers. They'll rate their experience, or more specifically and more appropriately, the food from disgusting to delicious. So yeah, there's natural ordering. So all levels of measurement have uh, all four levels categorize and labels variables. But except for nominal, everyone else ranks categories in order. Everyone except nominal and ordinal has known equal intervals, and everyone except just ratio among all four has a true or meaningful zero. Why is that? Because again, in interval, it's temperature, right? So 0 degrees or 0 Kelvin, uh, it just it's not considered a meaningful zero. In a ruler, a zero is meaningful because, for example, you say that something measures, well, something has to measure a certain value, right? But 0 centimeters or 0 kilometers is a meaningful zero. It matters in the real world, if you get what I mean. Statistics can be broken down into the following areas. We have sampling methods, descriptive statistics, and inferential statistics. These two have already been introduced earlier. Let's focus first on sampling methods. So we cover how we collect. It covers how we collect our data, and is arguably the most important area of all of statistics, because without this, how do we? There is no data to interpret in the first place. So we need to find ways, usually ways that are considered credible or accepted in trying to investigate a certain uh, scientific inquiry in the real world. So it ensures that we collect our data in just the right way so we make valid conclusions later on. It helps us know when we have just enough information for further analysis. Descriptive statistics, remember keywords summarizing and highlighting important aspects of the data. So yeah, describe information collected using tools and using a graph, calculating simple averages. For inferential statistics, you make predictions. Predictions, that's a keyword for inferential. You take a small bit of information, you analyze it carefully, and see for uh, have a lookout for inferred conclusions on a bigger picture. So technology can be utilized for statistics, but decisions are still yours to choose. What are the basic terms to know in statistics? Blank refers to the total amount of things. This is the population. Things, or maybe in a more humane way, humans, in the context of population. Sample refers to a small part of the population that is used for study or to examine and extract information from. Again, this is a portion of the total population. Sample size, this refers to the total amount of things in a sample. And for variable, this is what we're studying. It's categorized, it can be countable, it can be measurable. It is measurable. It represents a characteristic of what we're trying to study. Okay. What type of data is, okay, this has been tackled already. Different methods of obtaining a sample. Good luck. I won't. How many flashcards do we still have to finish? I think we've already had a rundown on most of it. We're almost done actually. Let me see what I can do in explaining this part. So this occurs when one or more parts of the population are favored over others. This is for exploratory and qualitative research. Biased or non-probability sampling. We have 5 subcategories under non-probability sampling. We have voluntary response, convenience, quota, snowball or referral, and purposive or judgment sampling. In the second common method, general method, we have unbiased or probability sampling. So one that is representative of the entire population, it gives each thing an equal chance of being chosen. So an equal chance of being chosen also means being unbiased. Unlike this, it's biased because you're not choosing candidates out of a random order or randomly. So we have how many? 1, 2, 3, 4. 4 subtypes under probability sampling. We have stratified random, multi-stage or cluster, simple, random, and systematic. Okay, so first let's go here. So voluntary response means, well, it consists of people that have chosen to include themselves. So from the word voluntary, uh, respondents have chosen to include themselves in the study by their own. Convenience sampling, on the other hand, from the word convenience, uh, usually your respondents are people who are easy to reach. So it's biased in that sense because you're only gathering respondents who are easy to reach. So it's not exactly the best kind of sampling in most circumstances because it can relay or propagate inaccurate information. Well, maybe not the word inaccurate. I think the more appropriate word is less credible. Because if you're looking for example, your study is about, at least for the respondents, you're looking for grade 12 students, but not everyone near your area are grade 12 students. So yeah, in that basic scenario, it just proves that convenience sampling isn't the best. Quota sampling, I didn't put any definition here. Good luck. Try to find a definition on your own. Uh, I blame myself. The person who made this more than a year ago, that's the same person as me. I didn't know. Wait, there's no definition there. Snowball sampling. This is if the population is hard to access. So usually homeless people are involved here. You recruit participants via other participants. So referrals basically. Purposive or judgment sampling. A researcher uses their expertise to select a specific sample most useful for the research. So not everything is dependent on technology. Usually, there are times, such as here in this kind of scenario, where you need to use your own judgment and educated considerations. So yeah, what you think is most useful for the research, of course, you back that up by data information to make it reasonable. You know a phenomenon, then well, you intend to know a phenomenon in this kind of sampling than to make statistical inferences. So there is a clear criteria for inclusion. For example, I think in high school back then, this was a kind of sampling that I did. So basically, I intended to, well, what I did was gain respondents who are workers from two cities. I think from each city, I had 50 respondents. The minimum amount of respondents you can have in a study to get something credible um, is 100 respondents. So from each, actually, I made more than 100 respondents. I had maybe, I think, 113, but at least it's not the bare minimum of 100. I had 13 more. So yeah, they had specific characteristics. They are workers from those cities, and I I intended to identify using uh well, I let them answer a specific questionnaire about uh how well their eyes performed in work and in um daily living basically. So there is a specific criterion for who can participate in your study. I used a specific sample. I selected a specific sample most useful for the research, for identifying um, what I needed to find out. That is how healthy are the eyes of workers from those two cities. Okay, 2A, stratified random. You divide the population into strata, or groups of similar people. You take stratified random sampling from each stratum to get the full sample. This is most appropriate to use if you want to make sure that Whoever is administrating the sample gets in contact with each kind of group or stratum. 2B, cluster sampling uses a combination of two or more uh, okay, SRS means simple random sampling, not stratified, based here. Two or more simple random samplings are used in cluster. You go through different stages of simple random sampling to find where your sample comes from. For simple random sampling, this is the most basic type from the word simple. So, in other words, abbreviated as SRS. Each individual in a population has an equal chance of being chosen to be surveyed. So again, this is not biased. Everyone has an equal chance. 2D systematic sampling, there's a list of individuals. They'd basically be divided into discrete groups and they'd be assigned to a number. Individuals from each group are gathered at regular intervals. I can't explain more than that. Tools to pick things randomly, we have something called the RDT, or the random digits table. This can aid in helping perform simple random sampling. Blank is the total amount of things, people, cats, population. Okay, we haven't had this flashcard yet. This is qualitative, just kidding, categorical. Values that place things into different groups or categories. Categorical variables, we have two types. Categorical in ordinal and categorical in nominal. For ordinal, we have, for example, letter grade, logical ordering to the values of a categorical variable. For example, A is, 90 above, I guess, and F is fail. So there's a ranking. Coming from fail to highest, we have F, E, D, C, B, and A. Highest is A plus, right? Okay. Categorical and nominal, there is no logical ordering to the values of a categorical variable. For example, aside from these examples, another is your name. Your name is very unique. You may have the same name as someone else, but technically there's no logical ordering that we can apply. Okay. Quantitative data, this is data that's measured in numbers. It deals with numbers that make sense to perform arithmetic calculations with. So there are two types, discrete and continuous. Discrete refers to the variables that can only be measured in certain or whole numbers. So, for example, the number of pets you own, the number of cars you own, the number of businesses you own, etc., etc. For continuous, it can take on any numerical value. So height, for example, your height is 182.7 centimeters. Your weight is 52.5 kilograms. Your midterm score is, I haven't seen a midterm score yet before, I think. But yeah, it can be a decimal value, basically. Okay. Main levels of measurement. We have types of data, nominal, ordinal, discrete, and continuous. The main levels of measurement are ordinal, nominal, interval, and ratio. What is this? This is the collection and interpretation of data. Statistics. This is used also to measure and analyze variability and is often hailed as one of the most useful areas of mathematics. This is the science of collecting, summarizing, and analyzing data. So we have two types, inferential and descriptive. Okay, for descriptive, we can use histograms, graphs to describe certain data. For inferential, it deals with taking a sample and analyzing that sample to make judgments or claims about a population. Maybe an example could be 4 out of 5 adults experience appendicitis at one point in their life. Well, that's not that's just an example, a made up example. It's not exactly true in real life, I know. Appendicitis is very rare. it can't be that common in the adult population. But yeah, you make certain judgments or claims about the population based on data, credible data. Sampling is used when observing all population data could. What is this? I don't get this flashcard. So I think we need to choose from these three. One of these three is correct, two are false. I'm not sure what this means. We'll skip that. What we measure from each individual is the variable of interest. Well, the way we measure these variables lets us know if the variable is quantitative or categorical. For quantitative, we have this. Categorical, A plus, B, and C plus, stuff like that. Categorical data is the manufacturer of your car. Your college major is also categorical data. The number of college credits you are taking is discrete numerical. This is assuming that college credits are whole numbers. Some universities have a different perception of college credits. Some can, some college credits have a decimal value, so it depends on the college actually. The manufacturer of your car, for example, Toyota, it's categorical data. You can't say any numerical value to it. There's no numerical value to it. As well as your college major, for example, BS Criminology. So, yeah, it's categorical. There's no number. Number of hits in Game 1 of the next World Series. Ratio level of measurement. Ratio, because there cannot be any negative number of hits. So again, 0 is significant. If we say we have 0 hits, that's a significant value. Temperature and opening day, that's interval for letter D. Letter C, field position on a randomly chosen baseball player. Position, that's nominal. Relative standing in the American League East among the 5 teams. So standing is, in a way, ranking. So that refers to ordinal level of measurement. Salary of a randomly chosen American League pitcher. We're talking about salary, so this has to be a numerical value. And there cannot be a negative salary, therefore, this is ratio. Letter F, freeway traffic on opening day, whether it's light, medium, or heavy, it's a rating, so this is obviously ordinal level of measurement. From the least number of cars to the most number of cars, described in terms of the following adjectives, light, medium, or heavy. If we're talking about the number of cars in a certain freeway, then definitely that's ratio. Yeah, ratio. Because there can never be a negative number of cars in a freeway. Okay, we've been there. Indicate which level of measurement is being used in the given scenario. The teacher of a class of 3rd graders records ratio level of measurement. So a class, well, if we have 0 students in a class, that's also possible. But we can't have -4 students, for example. So that's ratio. Teacher of a class of 3rd graders records the eye color of each student. So let's say green eyes, blue eyes, brown eyes, black eyes. That's nominal. Records the letter grade for mathematics for each student. If it's letter grade, that's automatically ordinal. So from failing to excelling. The teacher of a class of 3rd graders records the percentage that each student got correct on the last science test. Percentage, so this is ratio. We cannot have a negative percentage value in the context of our scenario here. 0% of students is a possible number. Okay, number 5, a meteorologist compiles a list of temperatures Celsius for the month of May. So this is interval. Uh, we can have negative degrees Celsius as a temperature value. So that's interval, can't be ratio. Number 6, a film critiques the top 50. So that's ordinal. We have a ranking. Number 7, how many numbers do we have? Until 20. Wow. The roster of a basketball team lists the jersey numbers for each of the players. This is nominal. Although the jersey number is a number, it doesn't have, well, it's just a number. It just associates itself with the name of the player. So there's no order in jersey numbers, so you can't say that it's ordinal. The jersey number is associated to the person. That's just what I just said. It's not quantitative in any way. Number 8, a local animal shelter keeps track of the breeds of dogs that come in. The kinds of breeds, for example, huskies and wieners. Uh, it's nominal. A local animal shelter keeps track of the weights of the dogs. This is ratio. There cannot be a negative weight value. Number 10, identify the scale of measurement of the following. This is ordinal because we have a scale of measurement. So military title is ranked according to superiority, if I'm not mistaken. So lieutenant, captain, and then major. Number 11, which is the corresponding measurement for the following data? The senator's name is Sam Wilson. This is a name, so that's nominal. It's not a quantitative matter. Which is the following corresponding level of measurement for the following data? The senator is 58 years old. So we're talking about age. There can never be a negative age, so this is ratio. Number 13, which is the corresponding level of measurement? The years the senator served are 2000, 2006, and 2012. This is interval. This is one of the most difficult questions actually. Interval usually is associated with temperature, but this specific scenario also pertains to interval. Annual salary of the senator is $800,000. You can't have a negative salary. So you're being paid to work. You're not paying to work usually. So this is ratio. Yep. $0 is possible. Zero has meaning in the context. The senator's marital status is married. Nominal. Okay, so whether it's married, single, widowed, or prefer not to say, that's gonna be nominal. Not ordinal. There is no ranking. It doesn't make sense to rank the statuses. No marital status is more superior than the other. Number 16, a magazine claims the senator ranked 7th in the polls. Ranking, that's immediately ordinal. Ranking from lowest to highest in the polls, this time through numero or number. Number 17, GRE. Scores range from 200 to 800. So this is interval. There is no zero score, so it's not ratio. Okay, so I think this makes sense. Another application for interval is, well, if you have a score range and zero is not involved there, perhaps you can say that it's interval. My question is, well, I'm not really sure about the answer either. What if we have a range of scores from 0 to 800 instead? Will that still be interval, or is it enough to consider it to be ratio? I'm not sure. We'll leave it to that. Number 18, evaluation by reading groups. This is ordinal. Evaluation by reading groups. I think there's a ranking in the context of this scenario. Number 19, assign a rank based on the number of applicants received. So there's a rank, so that's ordinal. Number 20, the number of children in your family, ratio. There can be a minimum of 0 children. Okay, we've been here already. The miles on your car's odometer, this is numerical. Is it continuous or discrete? An odometer value can be If I'm not mistaken, there can only be uh, a whole number, but in reality, uh, I think decimals are also present. It's just not seen in the odometer, at least in some. I'm willing to bet this is continuous numerical. Nope, discrete. Okay. Letter B, the fat grams you ate for lunch yesterday is continuous numerical. We're talking about measurement, so grams. There can never be negative grams. The name of the airline with the cheapest fare from NYC to London, categorical data. We're talking about the name of an airline. The brand of a cell phone you own is also categorical data. Nominal, in a way. Okay. Okay. We're finished. Thanks for watching. I'll see you in the next, if there will be a next.